Okay, 11.2. So it's important that you understand that a square root is what number times itself 2 times equals the radicand. What do you think is the probability that your next quiz that you have is going to have the terms index, radicand, and radical sign? High probability or low probability? Yeah, so why are you going to miss those? The only reason you would is if you don't go back and review and go over your work. All right, don't miss those. So what happens next is we're going to try now to deal with radical equations. What's a radical equation? Well, it's simply this. The variable is in the radicand. And you now know what that means. The variable is in the radicand, or I could have said is part of the radicand. The variable's underneath the radical sign. It's part of the radicand. That would be the idea of a radical equation. All right, so we're getting radical today. Math is radical. All right. First thought, and this is a key overall concept involving not only radical equations, but exponential equations. And they're coming a couple days down the road. So here's the thought. Inverse operations undo each other. Inverse operations undo each other. All right, so let me try to get you to understand what I mean. To isolate the variable of n, and this first example is an x squared. You don't need to circle it. I'm just trying to focus your attention. So to isolate the variable of an x squared, you want to get the x all by itself, not an x squared all by itself. You need to get rid of that squared. It needs to be just the x. That's isolating the variable. And how do we do that? We simply do it. We would take the square root of it. We would take the square root of it. So you can see right here, we've got that example, the square root of x squared. And the answer is the base of the radicand, it's supposed to be black, which is simply x. And here's the reality in a nutshell. Square roots undo squares. You had an x squared. If you take the square root of it, the square root undoes the squared. And there you are. Don't need to write this in your notes. I'm just trying to get you to think. But let me show you an example. You don't need to do this. Let's suppose we had 3 squared, right? So in this analogy, again, don't write this. The analogy, we're trying to get to the 3, right? We don't want the 3 squared, okay? So what we're saying is a square root will undo the 3 squared and get you to the 3. Well, what is a 3 squared? What's the square root of 9? Didn't it get us to the 3? It did, because square roots undo squares. They undo each other. And what you're left with is whatever it was that was squared. Square roots undo squares every time. Now the concept that we're going to get involved with today, what if you have the square root of x? Notice the x is the radicand. It's under the radical sign. We want to get to the x. We can't solve an equation with square root of x. We got to get to the x itself. We've got to get rid of that square root. And how do we do it? Well, you use the inverse operations and you simply square it. You square it. Because square roots undo squares, and squares undo square roots. They're inverses of each other. They undo each other. So if you look at the example here, We had the square root of x, and I want to get down to x, so I'm going to square it. What do you get as a result? The radicand dx. We were able to get to x by squaring a square root. So squares, that should be green, squares undo square roots. That's what we're going to use for today's lesson. We'll use this part on a lesson a couple days down the road, okay? When we do that kind of equation. So radical equations, that's what we're going to do. Squares undo square roots. Okay, just throwing this out there. What if I had let's go back to the first example, right? X squared, square root to undo it. What if I had an x cubed? How would I undo an x cubed? Raise your hand. How would I undo an x cubed? I undo an x squared by taking the square root. How would I undo an x cubed? How would I do that? Nick? No, that makes too much sense. That just makes way too much sense, right? Square roots undo squares. A cube root undoes cubes. That makes way too much sense. Math is unintelligible, right? Makes no sense at all. Who could understand it? Oh, wait, this isn't English. This is math. Yes. No, that's it, right? A cube root undoes a cube. What if you had something cubed? What if you had the cube root of x? How would you get to x? Cube it, right? Cubes undo cube roots. That's the way it goes. It's that simple. It is that simple. It is that simple. Okay, so what's the actual procedure for solving a radical equation? Number 2, how to solve rad equations. Getting rad today. By the way, the radical police will surely be visiting either your homework or quiz or test paper. So you don't want that. They'll issue you citations. It's not good. Okay, so we already know that to solve a regular equation, our goal is to isolate the variable. How do we do that? Things added to the variable, we move by adding their opposite to both sides. Things multiplied times the variable, we move by multiplying by the reciprocal. There are a few other things involved, like the last example of the homework, where you may have to do some distributing, and you may have to move even the variable all to one side. But that's the basic gist. Well, for a radical equation, we're not there yet. We've got to do a couple things first. First thing, your first goal, the first thing you're after, and that's why it's number 1, is isolate the radical. Get the radical all by itself. Once you have the radical all by itself, what undoes square roots? Squares. Do you think it would be legal? Don't write this. Don't write this. I had something like this. So I know a square is going to undo that square root. Would that be legal? Is that a legal maneuver? Not quite. What would make it legal? By doing what? Yeah, by doing it to both sides. So once you isolate the radical, now you're ready to square both sides. You got to do it to both sides. Once you isolate the radical, you're ready to square both sides. And then you know what? When you're done, you may not quite be done yet. Some simple ones, you're done. Other ones with a little more flair, you have to finish by lastly, then isolating the variable. So the simplistic ones, you don't need step 3. The ones that have a little bit more to them, you have to finish by now isolating the variable, and you'll see that in a minute. Okay? So that's not hard. We already know isolate the variable. You just got to think, oh, radical equation. Isolate the radical first. Look, this is what your brain has to say. See, some of you that struggle, you don't bother to get stuff like this and memorize stuff like this. That's why I put questions like this on the front of your test. Because when you come across a radical equation, the first thing in your brain should be, I got to isolate the radical. I got to isolate the radical. I got to isolate the radical. That's how you solve it. That's what's got to be in your thought. That's got to be in your thought. That's got to be in your thought. So again, this is something that tells you how to solve the thing. And we know how to do everything from there. We know how to do all the rest of the stuff. You just got to know what order to take it in. All right, let's do A. Get this a little higher here. I should have kept my shade up. Here, let me get my shade back. Oh, now it's going to be way up there. Come back. Come back. All right, there we go. Better. Move this guy back out of the way. All right, so we're looking at example A. Pretty easy. You see how the radical isn't isolated yet? Because you see how that positive 2 is on the same side with the square root of n, right? I'm sure we have no earthly idea how we're going to move the positive 2. Do we? Math makes sense. How are we going to move the positive 2? Say it. Add its opposite to both sides, right? It's easy. We know how to do this. Going to move the positive 2. It's added to the radical. We'll move it by adding its opposite. All right, where are we at? I'm going to keep the square root in red. Square root of x equals 5. Oh, look. We've isolated the radical, right? So what do you do when you isolate the radical? Square what? Square both sides. So take your green, square the left, square the right. What do squares do to square roots? Wipe them out. Leave you the radicand. They leave you what's underneath the radical sign. And that's an x. And we all know 5 squared is 25. Not 10. 5 times 5, right? 25. That's it. That one's done. You can go back, check your answer. Put a 25 back in for n. What's the square root of 25? What's 5 plus 2? 7 equals 7. Got that one right. By the way, when you're taking a quiz and a test, should you be doing that right after you do the problem? No. You got to do the whole test first. Then you come back and start checking stuff. You don't have time. Then you get caught up with not finishing the test because you're checking when you shouldn't be checking yet. You don't have time. You got to get through the whole test. Carson, do you have a question? Okay. Let's do the next one. Somebody raise their hand and tell me how to go about isolating this radical. John? Won't work on this one. Won't work on this one. This one doesn't quite look like. Antonio, you need to really pay attention because you struggle with equations. Ashton, what do you want to do? Okay, so I'm going to say it the normal way, and we'll do the shortcut on the next one. Things multiplied times a variable, we move by multiplying both sides by the reciprocal, right? I'll do the shortcut on the next example. We're going to multiply both sides by 1/3, right? Isn't it the 3 over 1 we want to move? What's the reciprocal of 3 over 1? 1 over 3. That makes the 3's divide out, and look, the radical is all isolated, isn't it? We move that 3. Of course, we all know 18 divided by 3 is 6. Oh, I got the radical isolated. So, class, what do you want to do next? Say it. Square what? Square both sides. Can't forget to do it to both sides. Squares undo square roots, leaving me the radicand of x. 6 squared, 36. Rolling on to the next one. Now, if it's an odd problem, I'll stop and check the answer sheet. Takes 2 seconds. It's a homework. All right, here's one with a little bit more meat to it. No potatoes. All right, so somebody raise your hand. Tell me what to do first. What's first? Or do you guys want to do it? Do you guys want to do it? We'll do it together. You'll do the next one. All right. Blake, what do you want to do first? All right, so because Blake answered this question that's been on every test since equations. When quantities are both added to and multiplied times the variable, move things blank first. What goes in the blank? Did he just try to move things added? That's why I taught you that. That's why I taught you that. That's why it's been on every test you had so far, short answer on the front of your test. So somebody else raise your hand and tell me what we want to do first. Jordan, what do you want to do?
Add the 5's opposite.
So what is 5's opposite? Tell me what to add to both sides. I agree. Let's add a -5 to both sides. We still have the -2, the red square root, the black y. And class, on 3, everybody tell me what the right-hand side becomes. So let me give you a second. Don't say anything yet. Not until 3. Here we go. 1, 2, 3. Because everybody says 7 negatives and 5 more negatives are 12 negatives, right? Okay. Blake, what do you want to do next? Yeah, and we'll do the shortcut now that I reviewed. So because it's not a fraction out front, what would the shortcut be? Do you know? No, the shortcut's a little easier. What's the shortcut? Why? All right, how do you say it? Who can say the shortcut in words? Nick? Divide both sides by -2. That's the exact same thing as multiplying by the reciprocal because the top is a 1. All right, and we've been doing that. We've been using that shortcut. Okay, that's a little easier and quicker. Now the left is red square root, black y. Negative divided by a negative is a positive, so hopefully you got a +6 answer. Oh, we've isolated the radical. It is now time to
Square both sides.
Square both sides. And squares undo square roots, so we get y, and 6 times 6 is 36, and that one's also 36. Just so happens to be. Person. Nah, it looks like an N to me. Yeah, I just changed it. All right. D. Yeah, you're right. It's an N. No Kool-Aid for you. D. All right. I think you guys are ready for D. Hey, by the way, let me pause for a second. Listen. Let me just go back 1 second and re-emphasize a couple things. Some of you that think the steps in the work don't matter, the steps in the work absolutely matter. So let me remind you of a few things with equations. Notice my equal sign 1 per line. Don't do this in your notes, just look. Notice how I have a left side and I have a right side. Notice how I add the exact same thing to both sides. Notice how the next line is what's left. Then I'll divide both sides by the same quantity. The next line is what's left. Take the square of both sides, and finally I get to my answer. I've got a right side, I've got a left side, I've got 1 equal sign per line, and the next line always comes from what's up above. That's the proper way to do your work and get things going. With that cyclone next to my daughter, I'm leaving my phone on and see if I get updates. So anyhow, that's what that is. That's my phone. All right, go ahead and solve it. See what you can do. All right, for time's sake. So hopefully you said to yourself, I'm going to move the 4 first because the radical's on the right. I'm going to move it to the left. I now have 8 equals 2 times the square root of x minus 1. Now in your quest to isolate the radical, you're going to move the 2 by dividing both sides by 2. Right? Trying to isolate my radical sign. Oh, my radical is isolated. It is now time to square both sides. 4 squared is 16. What do squares do to square roots? Wipe them out. What's left? X minus 1. Am I done? No. Is my variable isolated in this one? Not yet. Now I can isolate the variable by adding the opposite of 1 to both sides. Final answer, how many got 17 equals x or x equals 17? And what happened to the rest of you? Look, when you look at it, did we do anything unusual? Not a thing. The only thing we've done new is squared both sides, and we already know how to do that. That's easy. Squares undo square roots. Okay. Now you did have to do 1, 2, 3, 4 steps, and you got to be 4 for 4. But none of those steps were hard. And look, the radical happened to be on the right-hand side. I don't know, did some of you try to move the 12? Why would you move the 12? The 12's already on the opposite side. The 12's already away from the radical. What do you got to move? The 2 and the 4. And what do you move first? Things added. And what do you move second? Things multiplied. And away you go. Okay? So hopefully you guys will get better at those tonight. Number 4, note, if once the radical is isolated, notice those words, once the radical is isolated. You have to get the radical isolated first. If the other side is negative, then there will be no, not applicable, no real number solution. Don't put NA. The radical police will cite you. So here in the first example, there it is. Isn't our radical isolated? I do not want to square both sides at this point. It will give me a false answer. Did you hear that? A false answer. Oh, it'll give you an answer. You'll say n equals 9, but that's false. That's false. Because we're looking for principal root solutions. Later on, when we get better in our math and get higher in our math, we'll begin to look at all possibilities. But right now, there's no real solution. And we don't do anything at this point. I don't square both sides. I stop and say, oh, my radical is isolated. The other side's a negative. And I say, no real solution. That's it. That's all I do. No real solution. So notice in B, on this one, everything looks good right now, right? But the problem is our radical isolated? No. And look, I don't care what's in the radical, in the radicand. I could have a 3x minus 7 underneath the radical sign. It doesn't matter. My first goal is to isolate the radical, and I'm going to add a negative 7 to both sides. So here I'm going to keep my 3x minus 7 in there. And when I get to the other side, I say, oh, my radical is isolated, but the other side is a negative. I don't waste any more time. I don't do anything else. I don't square both sides. I say, no real solution. Because the other side is a negative when my radical is isolated. Now, this is only for square roots. We're not doing cube roots, but just for your interest, you can get a cube root to end up being a negative answer. For example, negative 2 times negative 2 times negative 2 is negative 8. That one works. But anyhow, it's another story. Don't worry about it. That's the idea. That's the lesson. All right, so what do you got for tonight? 3, 5 through 7, 10 through 14. I think I have it on your sheet, right? 21, 24, 26, 31, 34, 44 to 47. Any last questions? Anybody else? All right, stop. Before you pack up, one last second here. Give me 1 second to review with you. So remember, squares undo square roots. Therefore, when you see a radical equation, what should your first thought be? Isolate the radical. From there, square both sides, and then isolate the variable, and voila, you're there. All right.